Welcome back to another exciting edition of Mr. Hall's Classroom. We're about to get started where we left off last time in an exciting edition of learning about geometric shapes, and this time we're going to be learning about how to imply triangles and quadrilaterals. So, if you would, please join me on good old page 346, and we shall commence. On page 346, we're going to look at three different types of triangles. So it says a triangle and quadrilateral are the most commonly used polygons. We said the interior of a triangle measured how many degrees last time. So the interior triangle equaled 180. And I'll use this because it's going to be a quad. Was 360, and that's the degrees. So if we look at our givens over here on page 346, we have a acute triangle, a right triangle, and obtuse. Alright, so with acute, that means no sides are equal. With a right, you can have at least two sides equal, and with an equilateral triangle, you can have three sides that are equal. So, let's look again. I may have said that wrong, so I apologize. Scalene, so have no equal sides. Isosceles, and equilateral. I'll put A first. So let me go back here. Scalene, no equal sides. Isosceles, at least two equal sides. And equilateral, three equal sides. Alright, so let's take a moment here and move on to our definitions of quadrilaterals. If you would, on page 347, it says a trapezoid is a quadrilateral with at least one pair of parallel sides. Well, what are parallel lines? Parallel lines are lines that run like railroad tracks. They never touch. So a trapezoid has at least one. So that means would a square be a trapezoid? No, because if you had a square, it has two. You have parallel lines. These are parallel lines because they're running up and down. And then you have going across. So what that's saying is when these go right here, they never touch. And when these are going up, they never touch the railroad tracks. Now a trapezoid would give us a little something like this. You might have these being railroad tracks, but one might go like this, and you might have one that looks like that. So even though, per se, these will never touch going top to bottom, these will eventually run into each other. So a parallelogram has two pair of equal sides, so this would be a parallelogram because it has two. This one only has one. So 1 and 2. With that being said, let's take a little look at example 1 if we would. Alright, so example 1 says find the measure of angle A and angle B in the parallelogram. If the measure is 72 and the measure of angle D is 108. So let me go ahead and write that out. So we got C, D, B, and A. A measure of angle C was given to us, and it said it was 72 degrees. And the measure of angle D was 108. Now my question is, if they're parallel, wouldn't that have to mean that they're pretty much making lines? So what I'm saying is, if they're making lines, do you remember what I told you guys a supplementary angle equals, which is just a basic line from last time? Just like this. The measure, if you looked at your protractor, would be 180. So if I know that, that tells me that if this is 72, this would have to be 180 minus 72. It tells me here, if this is 108, then that has to be 108 minus, 180 minus. And so that gives me 72 here if I subtract, and that gives me, what do you guys think over here? 108. So again, quick recap what happened. Let me draw again. So we got B, A, that does not look very nice. We were given these, the angles were 72, 108, and since this is going to be a line, it's going to be 180 minus 108 equals 72 for here. And since this is going to be 72, it's going to be 180 minus 72, and that gives us 108 for here. Alright, so let's move on and talk about a couple different shapes here now. If you'll keep looking on page 347, we're going to talk about a rhombus, a rectangle, and a square. All three of these are four-sided figures. And you guys have saw them ever since you've probably been, again, in 3rd grade or so. But it says a rhombus is a parallelogram with all sides the same length. Okay? So, can you tell me like something typically that has the same length that you guys can think of? Often I think of like probably a square of some sort. So, that means every side is the same. A rectangle is a parallelogram of 4 right angles. Meaning here, 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 and here. What are right angle measurements? They are 90 degrees. Alright, so what about a square? Well, a square is a rectangle with all sides the same length, and what else? Right angles. So that means every side is what? 90 degrees, 90 degrees, 90 degrees, 90 degrees. So who can tell me what the interior should equal? If we said triangle was 180, then that means the interior of a regular polygon should be 360. You guys are killing this. Alright, so let's go ahead and take a look at example 2 here. And this is a super short lesson, but this isn't introducing things that you haven't already saw. So we're kind of just going back, revisiting things that you guys have done in the past, and just learning a little more in depth about them, if you will. Alright, so example 2 tells us, it says that we have a rectangle, and we have side W, X, Y, Z. Okay, so let's go ahead and just write that down. A rectangle. And we have W, X, Y, and Z. It tells us that side WX equals what? Well, it says WX equals 7, so let's go find where we find WX. That means this whole line here equals 7. Alright, now it tells us that we have WZ. So where's WZ? WZ equals 5.5. So it says find the length of the sides. Well, guess what, guys? If we go back and revisit what we just talked about like a rhombus and all this, let me go back and find it. Maybe I didn't write it down. Yeah, I did. So this was a rectangle. This was a rhombus. And this was a square. Alright. It tells us that it has at least two sides the same. So if I write here, this should be the same as this side. And my top should be the same as my bottom. Alright, the sides should be the same and the other side should be the same because they're both parallel. So with that being said, let's go back and revisit our problem here. If I know the left side is 5.5, well, that should automatically tell me that the right side should be 5.5. If I know that the bottom is 7, then the top has to be 7. And I didn't write it exactly the way they did in the book, as far as like they did hang on, I'll write it the way they have it just so you can see it again for another rectangle. So they had X, Y, W, Z. And they said that on theirs, WX is 7, and WZ is 5.5. It doesn't even matter. The same concept applies, alright? So if my, I don't know why they still don't put that, there it is. If the bottom is 5.5, the top has to be 5.5. If the side is 7, this side has to be 7. Because these are parallel. And these are parallel. And guess what? These lines right here are parallel, so they're the same. So the left equals the right, and the top equals the bottom. And real quick, I just want to run through your skill checks with you before we close the lesson out. So go ahead and look at skill check 2 if you would. It says that we have to name each quadrilateral. So our first one's kind of built something like this. Alright, just going back and talking about the things that we already know. What did we say that having one pair of parallel lines was? Well, that would be a trapezoid. Because these right here are eventually going to run into each other and kind of form a triangle more than likely. But these won't ever touch because they're parallel. Number 3, we actually just did one like this in example 1. It's a parallelogram. Number 2, you got 4 right angles. What did I say that was? Well, if we went back and revisited 4 right angles right here, that's a rectangle. And number 4 would be a square. Now let's go ahead and look at let's do number 7. Alright, it says we're trying to find the measure of angle. Let me write it down. So we've got so I told you, if you know this is 60, this is 120, what do you have to subtract them for to find the sides. Well, the whole line equals 180. So you have to take 180 minus 60, and you have to take 180 minus 120. So the other one gives you, if this would be 120, and this would be 60. Because if I subtract that, that gives me 120, and this one gives me 60. And the sum of it should equal what? The entire should equal 360 degrees. Alright, so I guess you guys, I got a little sleepy right there, but as far as I know, that's all we're going to do on this lesson. As I said before, if you guys have any questions, you have my number. Please text me, call me. We can do a video conference. It does not matter. We want to make sure that you guys understand this material. And with that being said, my dear friends, well, would you look at that? Class is over, and I'll be talking to you later. I've been your friendly host for this math lesson. Thanks for joining in at Cody Hall's virtual classroom, and I'll talk to you guys later.